Welcome to The Explainer. So today we're tackling a research paper that asks a really wild question. What if a specific valley right here on Earth was laid out geometrically to perfectly mirror a famous pattern of stars way out in deep space?
Okay, let's just jump right in. What you're looking at here, on one side you've got the Bosnian Valley of the Pyramids. It's a real landscape right here on our planet. And on the other side, that's the Pleiades star cluster, nearly 450 light-years away. I mean, you literally couldn't pick two things that are farther apart, right?
So what if there is some kind of hidden geometric connection? That's the question at the heart of a paper by researcher Dr. Sam Osmanagic. And the whole point here is to move past just, wild speculation. This is about using hard data, math, and statistics to see if there's something real going on.
All right, so here's the central idea, the main hypothesis. The paper is proposing that you can actually measure a geometric match, a real correspondence, between key landmarks in that Bosnian Valley and the main stars in the Pleiades cluster.
And the whole goal here is to get way beyond just saying, hey, these two pictures kind of look alike. Nope. This is a super rigorous investigation. It's all about using precise measurements to figure out if the match between these two patterns is actually, statistically significant or if it's just a fluke.
So how in the world do you even begin to test a hypothesis like this one? I mean, really? Well, the author used a very specific set of tools, an analytical toolkit, to compare the two patterns. Let's break down exactly how it was done.
The whole investigation followed this really clear four-step process. It all starts with getting the data, and we're talking super precise stuff here. High-res LiDAR scans of the valley and exact star coordinates. Then, once you have that data, you run it through a whole series of geometric and statistical tests, each one getting more and more rigorous.
Okay, so first up, the analysis looked for something really specific. Distances between key points that follow the famous Fibonacci ratio, the golden ratio. It's this incredible mathematical proportion, roughly 1.618, that just shows up everywhere in nature. We're talking seashells, galaxies, you name it.
Next, they brought out a really powerful tool called Procrestes alignment. The easiest way to think about this is like digital tracing paper. You literally take the star pattern, you overlay it on the map of the valley, and then you can rotate it, move it around, and scale it up or down until you find the absolute best possible fit between the two shapes. It's a way of comparing the pure geometry.
And then for the final step, the ultimate reality check, they used a Monte Carlo simulation. This is how you rule out a simple fluke. The computer creates 100,000 random landscapes and runs the exact same analysis on every single one. Why? To see how often a match this good happens just by pure dumb luck.
So that's the toolkit. The big question is, what did it find? What happened when they applied all this to the actual data from the Bosnian Valley and the Pleiades? Well, the first big finding was right there on the ground. The analysis showed that 3 of the main summits in the valley, the ones they call the Pyramids of the Sun, Moon, and Dragon, they form a near-perfect equilateral triangle. Now think about that. That's a super precise geometric shape just appearing in a natural landscape. But it gets even more interesting. Remember that Fibonacci ratio we talked about? Well, when you create a spiral based on that ratio and lay it over the valley map, the curve hits multiple key spots perfectly. It connects the pyramid summits and even the point where 2 rivers meet. It just fits.
And this is the absolute core claim of the paper. You take a similarly constructed spiral, you place it over the Pleiades, and it does the same thing. It connects the main stars in a really comparable pattern. It's suggesting that maybe the same geometric rule is at play in both places, on the ground and in the sky.
Okay, so how well did the overall shapes actually match up? Remember that digital tracing paper method, the Procrestes alignment? It spits out a score that measures the difference, or the error between the two patterns. And the score it came up with was this. It's called the root mean square deviation, or RMSD for short.
So with this kind of analysis, the rule is simple. Lower is better. Anything under 0.1 is considered a really strong geometric match. And as you can see, the paper's result easily clears that bar. What that means is, once you adjust for the obvious differences in size and rotation, the basic shapes are incredibly similar.
Okay, so the geometric match looks really strong, but that still leaves us with the biggest, most important question of all. Could this whole thing just be a massive coincidence?
Our brains are wired to see patterns, even where they don't exist. So is that what's happening here? Well, this is where that final step, the Monte Carlo simulation, is absolutely crucial. It's time to test this result against 100,000 random scenarios and find out for sure.
In this chart, this shows everything. Each one of those little yellow bars is the result from one of the 100,000 random simulations. That's basically the distribution of what pure chance looks like. And the actual result they found in the Bosnian Valley, that's the red line, way, way over on the far left. It's not even close. It is a massive statistical outlier.
And being that much of an outlier gives us the statistical bottom line for this whole paper. And that number is a p-value of 0.021.
So a p-value of 0.021. What on earth does that actually mean? Let's break it down in simple terms. What it means is this: the odds of finding a geometric match this strong, or even stronger, completely by random chance are just 2.1%. To put that in perspective, in most scientific fields, anything under 5% is considered statistically significant. So this result easily clears that hurdle. The analysis is saying this pattern is very, very unlikely to be a random fluke. But, and this is maybe the most important point of all, the author himself is very clear about this. He adds a huge caveat. He stresses that what the analysis shows is a statistically significant pattern. It does not explain how that pattern got there or why. This is a purely geometric finding. It's not making any claims about history or who might have built what.
So, in the end, the paper leaves us with something really compelling. The data points to a geometric link between this valley and these stars that is statistically, well, really rare. It shows the pattern is almost certainly not random. But it leaves us hanging with the ultimate mystery. If it wasn't chance, then what created it?